Lesson 22-4 is going to cover solving right triangles. So we're going to be calculating angle measures with trig ratios today. So make sure you have your scientific calculator and your Springboard book open to page 315. Okay, so calculating angle measures from trig ratios. So remember our kind of setup for our trig ratios. If you remember SOHCAHTOA, that will help you kind of set up your equations here. So you remember what ratios go with which trig function. Okay, but I'm actually going to jump down just to this and kind of get to the whole part of it. So the way we find angles in a function is by using the inverse trig function. So on our calculator, I'm going to bring mine up here in a second. On our calculator above where it says sine, cosine, and tangent, you should see something that looks like sine to the -1 power. Okay. So if you look above the sine button, it says sine to the -1. Those are the inverse trig functions. So sine to the -1, cosine to the -1, tangent to the -1. Okay. Now we use the inverse trig functions when we're trying to find an angle measure. So in the previous lesson, if we were trying to find missing sides, then we just use the regular trig function. But we always use the inverse, trig ratios when we are trying to find the measure of an angle. Okay. Now you would set up the ratio the exact same. We just change what we do when we actually put it in our calculator. So I'm going to go through 2A and B. Okay, but using your scientific calculator, evaluate each of the following to the nearest tenth. Make sure we're in degree mode. Remember, if you go to mode on your calculator, degree should be highlighted. If it's not, change it because you'll get the answers wrong. Okay, but all you have to do is hit the inverse, of sine. So second sine will give you the inverse function. Now I'm just going to use 0.5 because I don't want to type in a fraction. It's the same thing. Okay, and there's our answer. The answer is 30. Okay, so remember the inverse sine gives you an angle measure. So our answer here is 30 degrees. Okay, same thing if I do the cosine, so the inverse cosine, of a half, we get 60. So 60 degrees. Okay, anytime you use inverse sine, you're going to be using, you're finding an angle measure. So make sure you label it. Okay, so I'm going to have you guys try C through F and see what you get for those answers. Okay, here are those answers rounded to the nearest tenth. As long as your answer is close, you should be good to go. Okay. All right, so when we have right triangle problems and they ask you to solve a right triangle, okay, those are the directions. Okay, solving a right triangle. That means you're finding all the remaining unknown measurements, so all the remaining unknown side lengths and all the remaining angles. Okay, so let's practice a couple problems where we solve some right triangles. Okay, so here we have this right triangle QSR. Okay, use the inverse trig functions to find the measure of angle Q. So I'm finding the measure of angle Q here. So here's how we do that. We're going to set up our trig ratios the exact same way we did before using SOHCAHTOA. Okay, so if I'm finding angle Q, let's look at what we're given. I'm given the opposite side, and I'm given the adjacent side, the next two side. So that looks like I'm going to be using tangent. Okay, so in order to set up my equation, I'm going to do the tangent of Q is equal to my opposite side, let's see, which was 65, over the adjacent side, which is 33. Now again, since we're solving for an angle measurement, we're going to use the inverse tan. Okay. So all the rest of this we have to do is just punch this in our calculator. So I'm going to do the inverse tan, so second tan, and I'm going to type in that fraction. So we had 65 over 33. Okay. So it looks like we have about 63.1 would be our measurement. So angle Q is about 63.1 degrees. Okay. Now to find angle R, so we know this is label it here. We're going to call this 63.1. Okay. Describe two ways that you could find angle R without finding the length of the hypotenuse. So how could you find angle R here, the last angle here in our triangle? Okay. Well, one way is to use, okay, that the triangle must sum 280 degrees, right? That's one way to do it. Another way to do that is if you're trying to find angle R, you're given the opposite side, okay, and the adjacent side again. So you can do the inverse tan again for angle R. Just set up a different ratio. So opposite would be 33 over 65 this time. So set up a little different. So there's two ways to do it, okay? Or the last way, if you remember from the previous lesson, angles Q and angle R should be complementary. So if you know angle Q, subtract it from 90 and you have angle R. Okay. All right, let's just finish up with number 5. Let's figure out some ways we can find the hypotenuse. So I'm going to let you guys kind of decide what you want to do and find the length of the hypotenuse for me. Okay, if you did it correctly, the hypotenuse, so QR, you should have gotten 72.9 feet. And as long as you're close to that, we're good. Okay, a couple ways to do it. One way you could have done is using Pythagorean theorem. Just abbreviating here for time's sake. Okay, that's one way to do it. Another way you could have used trig functions. So let's see, QR. I know the angle Q was 63, so let's see, that would be opposite over hypotenuse. You can use the sine function. So the sine of 63.1 is equal to 65 over x. There's one way to do it. Okay. We also know the adjacent side if we have to solve for the hypotenuse. So you could also have done cosine. This is, I guess, option 3. Cosine of 63.1 would have been, let's see, 33 adjacent over hypotenuse. Okay, and then I guess options 4 or 5 could have been using angle R. Same thing, using sine or cosine with angle R, okay, to figure out the length of the hypotenuse. Okay, so different ways to set up the problems. It's all the same thing using SOHCAHTOA, setting up your ratios. Just depends on what you're solving for. If you're solving for a measurement, you're just going to use the regular sine, cosine, tangent, a side length. That's what you're finding. If you're finding the measure of an angle, you're going to use the inverse trig function.